Hey, howdy. And welcome to the next of this series. Before we start, I'm gonna level with you real quick. This project is not even close to done, but I'm cutting myself off and releasing a video about it before I drive myself crazy, because I'm close to feature creeping myself into a coma with how much stuff I'm trying to add to this stupid thing. So I just need to cut myself off, upload this on GitHub, and then just move on before I drive myself crazy. So, welcome to Alchemy Deluxe, the second of PopCap's games, another super early game that's designed to be generally pretty easy to understand. Let's hop into a game and I'll explain how it works, but it's pretty simple. It's basically... Oh, that stupid skull. Is there anywhere this can even... Oh, okay. It can't be used. Usually it pops up with a symbol if it is unusable. So, this game is basically a combination of Uno and Dominoes. Or Crazy Eights and Dominoes, I suppose. Where you draw, every turn you draw a symbol, and that symbol has a color and a shape, and you can take it and place it anywhere that you want on the board where it's valid. And how do we determine if a move is valid? Well, we look at all of its neighbors, and if every adjacent tile shares either a color or a shape, then we can place a tile there. There we go. When placing a rune, it must match up with all adjacent runes in either its shape or its color. Yeah, I get it. So let me try... This is average difficulty, so I'm probably going to die eventually. I'm not gonna go for too long though, because the last time I tried to record this, I went for way too long and it was really awkward. So you might wonder, how do I build an AI off of this? Well, I'm gonna let you in on an unfortunate secret. I kind of cheated a little bit here. The end result that I came up with, like even if I wasn't trying to cut myself off here, the AI doesn't actually play this game. It runs a simulation that has the exact same rules, but it doesn't actively make moves or get a score. It's kind of unfortunate, but there are a lot of aspects that made that way harder than it had any right to be. Okay, I think this is a good enough time to stop. You get 3 chances, and those chances are refreshed whenever you make a move. When the chances run out, you die. Not my finest showing. Roger the Sure? I think that's supposed to say Roger the Shrubber, if I remember correctly. It's a Monty Python joke, but it became Roger the Sure, which I'm not sure what that means. Anyway, let's close out, and then let me just put this on so that it's running in the background. Oh no, you can see my YouTube recommended. The horrible secret that I have, at least in my opinion, I think I have good taste. Okay. There's a lot to unpack here. Let's start by going over the global variables, because there's options here. And a lot of them kind of explain themselves. Visual output, for example, it generates something basically like this. I just ripped some images directly from the game, and it plays out Alchemy, and the rules are basically identical. Which, this is damn cool, if I do say so myself. That is extremely cool. In fact, let me set the iterations to 1, visual output true, And I think these are the default settings. We could tweak those as we saw fit, but let's start with 4 shapes, 4 colors, an 11 by 11 grid, and a 5% chance of blocks. Now if we hop over to the canvas here, it's actually generating the images in real time, which is really cool, I have to say. So let's just keep going through these, and while we let this cook. Remove diagonal bias. Something that I noticed is, as we'll see in a second, this all relies upon a fitness function that takes in each move and then calculates basically how good is that move. Does it get you closer to winning? Does it get you closer to not losing? Does it match tiles? Does it open up more moves? Oh, it won. Oh, didn't win. That's a loss. Yeah, that's sad. And something that I noticed is that when things had identical fitnesses, it would inadvertently sort them by X and Y coordinates, so it would always trend towards the top part of the screen. So if I remove this diagonal bias and then I run it again, it's gonna run a lot faster, but there's a bit of a problem. Let's see if it'll show up. It's, instead of splaying out in all directions, it kind of like leans towards the upper right in a way. Yeah, there we are. You can see it a lot more here. Now, on paper this is pretty good, but there are situations where that's kind of just terrible, because there's a lot of situations where, especially when you have most of the board cleared, it will just keep making the same moves in these upper quartiles over and over and over again and not actually match new moves. It seems to be doing decently well for itself, but I don't have high hopes for it to actually clear out the whole board. Now, recursive fitness and recursive depth, I abandoned this aspect of the project. My original hope was for some sort of recursion to be used. Basically, not only does it check each move, it checks all the moves that could be made from those moves, and it was way too much strain on the system because it's already operating this slow. It was so much worse with recursion. Let me turn it on and show it off because it's kind of hilarious. Verbose so that it actually does it by move, and then let's see how long it takes for it to make one move. It's probably going to be running like that for the rest of the video. Oh no. Oh, that's because the recursive depth is 1. I mean, it's kind of working so far. But yeah, it is comically slow. So I'll mercy kill it. And then chances, shape number, color number, dimensions X, dimensions Y, that's about what you'd expect. I think there's an asymmetrical number of rows and columns in the actual game, but I went with 11 by 11 because it's a little bit easier. The block chance, I wasn't able to figure out what the exact chance of getting a null block was. I ended up just saying it was 5%, and that seems basically accurate. Now we get to these, and these are where things get really interesting. And let me just ignore this and ignore the load presets. Color map is just what we're using for the colors that appear on the board. I could change these to be whatever I wanted. But let's go follow this over to this function down here. This variable right here, actually I should talk about this one. This variable up here is sigil. This is just a wrapper that sort of contains all the information that we want to know about the different tiles. Their X, their Y, their color, their shape, and there's also a little function in there called match that works off of itself and another sigil, and it returns whether or not they match. If they do match, it returns true. If it doesn't match, they return false. Now, number of solutions, this should probably be further down because these are still like in the class declarations, but whatever. What number of solutions does is it runs through and it checks a couple of things. For all possible shapes and colors, for a given X and Y, it will make a temporary sigil and then it will check 3 things. The first thing that it checks is the sigil none? Or is the spot none? Is there anything at that spot where you're trying to put something? If the answer is no, then there are no solutions. The next thing that you want to check is, does the spot have neighbors? If there are sigils on adjacent tiles, then you can actually build off of them to form a solution. And the last thing that you want to check is, does the sigil match a neighbor? So it does all 3 of those things, and if that's true, then it adds 1 to the number of solutions. And then it returns however many that ends up being. Board state is a larger wrapper that contains all the information that we want to know about a current board state, a current game state. It has the current move, the current board, the current backboard, which is just a representation of all of the tiles that have been gilded, number of chances, and depth, which was used for the recursive function, but I axed it like I said. And now we get to the good stuff, the fitness function. Oops. So, I'm holding up my phone so I can actually find my script. So, the best way to explain this is to explain through an algorithm called A*. That imagine that you have a library full of 100 shelves of books. You know nothing about the books besides their titles, and you want to find a specific word within those books. Now, the lazy answer, or rather the greedy answer, is to just go to the very first bookshelf that you find, look through every page of within every binding of every book, go through every sentence and try and find that word. You could be searching for the rest of your life, especially if it's a hard to find word. Or you could go off of either your own knowledge or some external aspects like the Dewey Decimal System to look for a specific kind of book that will give you the highest chance possible to find your answer. Like for instance, the example that I've written down here is that suppose you want to find the word brother. Well, the easiest way to do that comes to mind for me is to look for George Orwell's 1984, because the sort of, what's the word for it? The antagonistic force in that book is Big Brother. So it would be really easy to find because Big Brother is always watching is everywhere in that book. Like that phrase repeats over and over again. So it would be a piece of cake to find. So how does that apply for our case? Well, what we can do is we can generate a list of solutions and then we can rate those solutions by a set of factors. And let's just go down that list of factors. Factor 1 is the gold malt. Does the move gild a tile? The second factor is does the move land on a gilded tile? And it's like kind of subjective for whether or not you want to do this. I haven't found it makes that much of a difference, but I have like a minor penalty if the system tries to make a move on a tile that's already gilded. A problem solver, how many moves how many moves were possible on that tile? and the result is inverted. So the less moves that are possible on the tile, the higher the fitness value. So in a way, we want to make moves that are difficult because we choose the sigil randomly, there's a good chance that you're not going to get another solution to that tile in a long time. Problem Maker, I ended up removing because it turned out to be a lot more computationally than I was hoping for. But in a perfect world, it would have been, how many moves does the move create, basically? Like, if you place down that move, does that open up more options? Does that constrict the options of the tiles around it? I'll have to revisit that, because it seems important. Seems a lot more important for a recursive approach, though, and like I said, I kind of threw that out with the bathwater. Likes neighbors, kind of simple. How many neighbors does the move have? I mean, how many neighbors does the tile have? And num sigils, it kind of goes without saying. How many sigils are there total? And right now, what do I have them set to? Gold Molt has a multiplier of 10, No Retread is a 1, Problem Solver, multiplier of 20, Likes Neighbors, multiplier of 1, Num Sigils, multiplier of 10. That seems to be the best that I could find. Maybe there is a simpler way to do. Maybe there's like a genetic algorithm that I could apply to this or something, but like I said, feature creep is going to kill me if I let it, and I need to like wrap this up and make a version of this that I can publish. So that it's, quite frankly, I want to move on to something else. And the last thing that I want to mention before we move on is this bit right here. This function is down here. This checks whether the backboard is fully gilded, and if so, it returns a really, really large number so that that move is always picked. And then update board. Update board is kind of like, it's like a function that I was planning on writing for the Bejeweled player, where it goes through all the horizontals, all the verticals, and if there's a completely filled line, then it will remove all the tiles in that filled line. All these four we're gonna skip because they were involved in the recursive implementation, and then, excuse me while I drink some water, we get to iterate, which what iterate does is it picks a random color and shape, and that will be basically our potential move. It will then initialize a new sigil, and then it will go through all possible options. And if it matches up, then it will append that option to this list up here. Then it takes that list, it sorts by the fitness, so higher fitnesses end up on, let's see. Yeah. Higher fitnesses end up on the bottom, if I remember correctly. That seems right based on this. No. It ends up at the highest stuff ends up at the top. It's just that this is a helper function that accommodates for the randomness issue that I talked about earlier. Because this is all from the diagonal bias. And then if it can't make a move, then it subtracts 1 from the chance, otherwise it adds 1 to the chance. Then it updates the board, and then it returns some stuff that can be processed further down. There's also a helper function here that creates the canvas. And this is what creates all the stuff over here. Oh god, the poor thing. Let me just like make let's make a small one. Let's go 5 by 5. With visual output. Oh, poor thing. It is not. Hang on. Let's bring this up to 7, just so it has like a fighting chance. This looks like a weird kind of flag. Hey, we got it. And then, let's see. Presets we can ignore, that was something I was testing. Alchemist notes we can ignore, that was storing the results to a spreadsheet, which didn't really amount to anything. What it does is whenever you want to run, it will delete all the files in that canvas folder. It will initialize everything, and then it will just go. While the board is not completed and the chances are greater than 0, it will just keep iterating over and over and over and over and over again. And then that'll be it. And what we can do as well is, let me get rid of the visual output, get rid of the verbosity, get rid of the tests, or have it print the tests, and bring that number up to 100. There we go, it took a second. If you notice, like at 7x7, it's actually doing pretty well. Roughly, I'd say like somewhere around a 50% win chance. Yeah. Now, if we chalk it up to 11x11, it's going to take a second. And while it's cooking, let me talk a little bit about my future plans for this. The next thing that I want to make is going to focus on a genetic algorithm, which seems very daunting, but I assure you, it's actually less impressive than this. The genetic algorithm I kind of just did in an afternoon. But the results are way more impressive, in my opinion. Like, it's a lot less work for a lot more credit, which is a great way to describe AI in general. Also, that's a 12% win rate, which isn't great, but for random moves, that's not bad. I think that, like, that's a little bit over what it usually is with no weights. I think without weights, if I just, let's see. Let's just like cut those off for a bit, and let's just make all the weights equal to 1. This should lead to a difference. And if it's not, well, that sucks. I think the next thing that I want to do is I want to do either the genetic algorithm video, or I want to do a video on word stock. Yeah, so it makes a significant difference. Let's run it a second time just to be sure that it's not just confirmation bias. But I either want to do a video on word stock because I feel like a video that revolves around words could genuinely be kind of fun, in sort of like a Wordle information theory kind of way. And it's an excuse to actually talk about word stock, because I don't think I've ever properly talked about that game on this channel before. But the weights definitely help. And again, I could use something more sophisticated to try and finagle what are the best weights for this. I kind of just went by eye, and this seems to work pretty well. So yeah, I think that's the long and short of it. As with before, I'll post a link to this to my GitHub page. If you're interested in checking it out for yourself, you will need Python, but I would recommend looking up how to get Python, because it's not that bad. And with that, that'll have to do it for me. Thanks so much for watching. This was fun.